Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain lab. Today I'm taking a look at another of these Fluke 8810As. They're digital voltmeters, multimeters. Measures DC volts, AC volts, and ohms, and does it on, well, let's see, there's 5 scales of DC and AC volts, and we have 6 scales of ohms. We have an uh, auto range switch as well, power on and off. We've got 2 and 4 lead input possibilities here. And it's what's nice about this also is that we have it's a 5.5 digit multimeter. So I fed in a volt of DC into this thing on the 2-volt scale, and as you can see, we are reading 1.4 zeros, 5 zeros, and then flashing a 1, plus or minus. So there's 5.5 digits of accuracy at that range. Going to the 20-volt scale, it's 4 plus 1. And then if I went to the 200 millivolt scale, you'd also have 5.5 digits, but I would have to reduce my input to demonstrate, but we'll see it in the calibration. It's a nice looking unit, no major cracks, breaks, anything like that. There was some template spray painting that was on it, so I did my best to remove it, couldn't get it off, so I masked off the unit and I sprayed the middle section and I sprayed the back. So you can see the back and the strip up the top here has been spray painted in order to remove the view of that annoying template. Outside of that, we have nice looking feet on the unit, and the nice specification sheet, a good handle. Everything on the front is in good shape and works. So, all in all, it's a nice little unit. We're going to take it through its paces. Bear with me and we'll do it. Okay, so we've got ourselves connected up to the Fluke 343A up there. We're outputting 100 millivolts into the 200 millivolt DC scale. And we're reading right now 100.001 to 2 microvolts on the end, so 100.002 and 100.0022. So looking at the verification chart, if you have 100 millivolts for which there is no calibration, as long as you're reading between 99.98 and 100.02, you're in cal. And yeah, we're there. We're right on the edge. We got 100.02, and we got some noise that kind of tracks with the HP over here. So that looks good. Let's go to the 2-volt scale. We see the 100 millivolts repeated on the 2-volt scale in the low end, which is good. Let's go ahead and take ourselves up. We want to go to 1 volt. Okay. We got 1 and roughly 6 zeros. And we're getting 1 and 5 zeros, plus or minus a digit on the readout. So we're good. Reading a volt. Let's go to the 20-volt scale. 1 and 4 zeros, a little flash there. So we're good on the low end. Now we want to go to 10 volts. So if I want to go to 10, I'll up it to 10. All 9s to a 10 with zeros. It looks good. And we are reading all 9s to a 10 right in the middle there. So that looks great. Going to the 200 volt scale. We start out with 10, which is looking good. We want to go to 100 volts. Adjusting for 100. 104 zeros, and we've got 103 zeros, so that looks good. A little flashing, but we're good. Going to the 1200 volt scale, we got 100 volts on the low end, that's good. And I'm going to want to change my my leads. I do not want to use coaxial leads for the high voltage, so we're going to disconnect ourselves. Okay, so we replace the coaxial leads with these independent leads. We try to leave a little spacing on them. Same thing with the leads going to the HP. And we're going to go ahead and go back to putting 100 volts on there. Alright. And then we're going to raise this thing. I'm going to take her up to 900 volts. Okay, and there's 900 volts, and we are reading 900.03232, about 900.02. So we are 2 or 3 hundredths of a volt off at 900 volts. So pretty small error at 900. We're going to take her back down again. Let's take off the voltage. We're reading a volt now on a 1200 volt scale, which that's great too. So DC wise, we look quite good. Just to double check here, 1000 volts. If I read between 999.87 and 1000.13, they said I was in cal. We did better than that. We were a whole tenth of a volt better than that. So let's go ahead and check the AC voltage, and we'll hook ourselves up. I'll get right back to you. Okay, well, we're hooked up to the Fluke 5200A AC reference, and we are outputting reference voltage of 1 volt on the 2 volt scale in AC. We are reading 0.99998 something on the HP. We're going to touch that up just a bit. All right. So we are on the AC scale. We got 1 volt coming in. We are reading either all 9s or 1 with all 0s on the HP. I'm getting 1 and 4 zeros, and on average I'd say about a 6. And that puts us on 1 volt. If we read between 0.99890 and 1.0011, we're good. And we are well within that. .0011 would have a 1 here. We're over in the last 2 digits, so we're doing much better. So let's move on. We'll go to the 20 volt scale. And we are reading 1.0008978. Still dropping a little bit. We'll check on that in a minute, but we're on the low end. We're reading 1 volt out of 20 to better than 3 decimal places. We're working on the fourth. We're down to 1.00065, 4. We're reading 1 coming in on the HP. Okay. On the 20 volt scale, we want to go up to 10 volts. 10 volts. I want to adjust it. There's 10 and 4 zeros. 10 and 4 zeros with a little bit of noise happening. It's happening on the HP, so don't think that it's just the Fluke. However, 10 on the 20 volt scale, if we read between 9.989 and 10.011, again, we are at least a decade better than that. So we're well within the limits of acceptability here, and we are in agreement, within, I don't know, within 500 microvolts in agreement with the HP, and that's out of 10 volts, so pretty good agreement. Let's go ahead and go to the 200 volt range. We see ourselves reading the low end, the 10 volts, getting 9.989. Alright, so we're just slightly low on the low end of the 200 volt scale. Actually, on this scale, they didn't want 100 volts, they wanted 50. It's interesting. $50.001, 50.008, and on the 200 volt scale, if we had 50.06, we were good. We had 50.008, so we're well within the display limits for being good at 200 volts AC. Let us go to the 1200, and there is 50.02, 50.00, 50.00 on both right now. So that's the low end of the 1200. That looks really good. And in AC, this is 750 volt scale. We've got 100, and we, as long as we're between 99.83 and 100.17, there's a 100.001, got a flashing 0. Okay, there's a 0. And we are reading 99.93. And if we are 99.83 or better, up to 100.17, we're good. And we are right now reading 99.93, so we're in there. So that does it for the AC scale. AC is calibrated, and it's within the acceptable voltage checks in the manual. So let's take a look at ohms now. We'll go ahead and shut this down. Okay, on the 10 megohm scale, putting 10 megohms in, we are reading all 9s to 10 with all zeros. So we're right there in the heart of it. And essentially they give us quite a range. We could go between 9.9797 and 10.02 and still be good, but we are right there. If we move around, we're going to see this thing go a little wacky. That's normal. It's picking up the field around my body here. Okay, let's go ahead and go to the 2000 ohm scale, 2000 kilo ohm scale, and put in 1. And we are reading all 9s to 10 with all zeros at 1 megohm. Alright, so then it says go to the 200K scale. 200K, it wants us to put in 100K. Alright, just popped 100K in there. And we are reading 99.996. And if we were between 99.987 and 100.013, we're good. We're 99.996, so we're well within that. Okay, we're on the 100 kiloohm scale, and we are reading 99, all 9s, essentially. And if we're within 99.987 and 100.013, we're good. And we are just about perfect, so can't complain about that. Okay, well, we're on the 10,000 ohm step on the resistostat. We're feeding into the 20 kiloohm range, and we are reading 10,000 perfectly, plus or minus a digit, but otherwise it's perfect. Let's take a look at the 2,000 ohm scale. We're going to feed 1,000 ohms in, and we got 1,000 ohms coming in, and we are reading 1.0000. It's flashing a 10120. I'm going to call it a 1. So we've got 4 zeros and a 1. And if we are between 0.99987 and 1.00013, we're good. Well, we're even better. So we're almost perfect. And finally, let's take a look at the 200 ohm scale. This is a range for which there is no calibration. You just have to be right. Let's take a look. There's 100 ohms. And let's take a look at our meter leads. Let's see. Wrong way. Let's take this. See what our meter leads come out to. We've got 0.172 ohms in those leads, apparently. Okay. And with 100 ohms feeding through those leads, we got 100.17. Yeah, it's about 100.163. So the resistostat has got a slight difference in it, but essentially we're right there. We're perfect. If we were between 99.97 and 100.03, and that you have to subtract the leads out, so taking that out, we would be almost perfectly zeros, 0, 1 maybe. So we got it. So the ohms is reading very well. So essentially we've done every test on here, gone through all the ranges. We have an auto position that works too. That's about it. So thank you for listening, and happy bidding. Somebody's going to be a happy boy with a nice meter for a good price. So until next time, bye.